While working on a steering mechanism for my robot, I wanted to record the current draw of the motors. The data would give me a rough idea about the friction in the mechanism so as to decide whether I need a different motor controller or different ideas. To fit the motors during testing, I use RuiDeng DPS power supply, which can provide me the data over Modbus. There is an app for Windows and Android to read it, but I couldn't find anything suitable for macOS. Given that Modbus is a standard protocol for connecting industrial devices, would it be a ridiculous idea to develop a generic library to use it with this power supply and other devices? It turned out that somebody developed such a library. Perhaps the best implementation comes from Scylla Embedded Solutions. The library is small and clean, and it supports different platforms, which is a huge plus. But I needed a bit more. Different applications that I have in mind would require me to duplicate the code that uses the library. That's how Bus Adapter project came about. The software generates a C++ interface for a program to interact with a Modbus compliant device, or for building my own. This post describes how I used Bus Adapter to get the data from the power supply. The first step is to create a model of the Modbus device. A model describes registers that the device supports. It may also contain other attributes that help to generate source code. The table below represents power supply's registers, which will be used to create a model. To automate assignment of register IDs, the registers are split into groups. The registers within a group are contiguous. The first register has an ID of start ID attribute. IDs of the following registers are incremented every word, which takes 2 bytes. Power supply's document indicates that there are 10 consecutive instances of the third group. Attribute repeat specifies that. The code generator will now add an additional parameter to the interface to distinguish between the instances. Decimal points are useful for displaying the values. The build uses CMake modules from CMake Helpers project. The modules implement common procedures for cross-platform development. To build reader and writer programs for the power supply, I use the following project structure. A root CMake list contains instructions to set up module paths and to include the module main project. The CMake file at the source directory configures some definitions and the main dependency Bus Adapter. Once the build is set up and the model is complete, I start the build process using a shell script. The script reads command line arguments, exports paths, and invokes CMake. At this point, the build is done and I store serial link parameters to a configuration file to avoid typing them on every run. After starting up the power supply, I requested to load preset number 2, which on my unit has output voltage set at 12 and maximum ups at 5. Next, I turn the power on. Now I can start recording the required information using DPS reader. The program logs the preset values as well as voltage and current being supplied. The goal is achieved. I can read and store the data from the power supply. The best thing, it only took me a short time to set it up.